Alright, today we're looking at note 7.5, exponential and logarithmic conversions. So we have been looking at the graphs of logs and exponentials, and we have noticed that a logarithm is the inverse of the exponential function. So log and exponential are inverses. In other words, a log is another way to write an exponent. Standard form for a log or logarithm is y equals log base b of x, where b is the base, y is the exponent, and x is what your exponential expression is set equal to. So we're going to talk about that here in a minute here. Remember that common log is when the log has a base of 10. Okay? In other words, if it does not have a base written, we assume that the base is 10. So if a log doesn't have a base written, we assume it's 10. So if you're given a log base b of x equals y, then in other words, what this means, it's the same thing as saying b to the y power equals x. Now that's only for these conditions, which we'll talk about later. But here's what I have been taught that works for me to remember. So if you're given log base b, that becomes your exponent, or excuse me, that becomes your base. The y becomes your exponent equals x. So I call it kind of like a heart method is what you're going to make to transform your logs into exponents. So let's look at Roman numeral 1. Write the following logs in exponential form. So based on what we have here, remember we started with the base, so that's 6. Start with the base, and then you go to what it equals. That becomes your exponent. So in this case, 3 will become my exponent. And then from there, that equals whatever's inside of the log. So equals 213, kind of like a heart method. Okay, a sideways looking heart. So on this one, start with the base. So log base 27 of 3 equals 1/3 is the same thing as 27 to the 1/3 power equals 3. Okay? So here, log base 5 of 125 equals -2 is the same thing as 5 to the -2 power equals 1/25. Okay? Looking here, we don't have a base written. Remember what is implied. If I don't have a base written, 10 is implied, so that's like 10 to the 2nd power equals 100. So if you wanted to make sure that you did all these right, you could go back and actually check these. So here is 6 to the 3rd 213. Well, no, because that's a typo and that's supposed to be 216. So I apologize. That should be 216. Okay, but looking over here, 27 to the 1/3 is 3. You could type it in the calculator to verify. This one you should know, 5 to the -2 power is the same thing as 1/25. And this one you definitely should know, 10 squared is 100. So we have converted our logs into exponentials correctly. Okay, so what if we want to go backwards? Write the following in log form. Okay, it's still the same heart method, except now since we've got an exponent, we need to create a log. So this would be log base 3 of 81 equals 4. Okay, log base 8 of 1 equals 0. Here, log, okay, we've got a base 10. Do I need to really write it? No. Of 1/100th equals -2. Okay, and last but not least, log base 4 of 64 equals 3. Okay, so now moving on to evaluating the following logs. So if you want to evaluate a log, you want to change it to an exponent because that's something we're more familiar with and we know how to work with. So let's take log base 8, and we don't know what it equals. So on all of these, I'm going to set them equal to x because I don't know what it equals. Okay, so log base 8 of x, that means x is my exponent, equals 32. Okay, so after I've done that, then to find out what x is, we want to make these have the same base because then we will know how to work with this. So 8 is the same thing as 2 to the third. Okay, so all I've done here is rewrite 8 as 2 to the third. Okay, equals, and hopefully you know that 32 is 2 to the fifth. Okay, and by your exponent properties here, when you have a power to a power, you multiply. So that's the same thing as 2 raised to the 3x power, because 3 times x is 3x, equals 2 to the fifth. So now that our bases are alike, we can set our exponents alike, because the only way that they'll be equal is if my bases are alike and my exponents are alike. So 3x equals 5. Okay, I just took 3x, set it equal to 5, and then to solve, divide by 3, I get x equals 5/3. Now y'all don't take my word for it, plug it in the calculator and check it. Plug in 8 to the 5/3 power and see if that equals 32. Okay, let's practice another one. So if I change this to an exponent, I've got 2 to the x equals 16. So on this one, I've already got base 2. I can't really go any lower with that. So 2 to the x equals 16 is the same thing as 2 to the fourth. So on this one, it's pretty easy to see that x has to equal 4. Okay, next one, we've got 4 to the x equals 2. Okay, on this one, change this to base 2, so 2 squared is the same thing as 4. Okay, and that's an implied 1, 2 to the first power. So here when we multiply, we've got 2 to the 2x equals 2 to the first, so 2x equals 1. When you divide by 2, you get x equals 1/2. Okay, last but not least, here without a base written, 10 is implied. So 10 to the x equals 1/1000th. So here you should know that 1000 is the same thing as 10 to the third. Okay, and the next step, you should know that since that's on the bottom and I want to get it up to the top, when I flip that guy over, that's going to become 10 to the -3. Okay, here that shows me that x equals -3 because they have the same bases, so set the exponents equal to each other.